Hi, and welcome back to Chuck's Corner, where I share real stories from CNC manufacturing. We were machining a part from DH36 high-tensile steel. The first operation used a 3-inch indexable face mill, and it cut beautifully. Nice smooth finish, stable cutting, no issues. Later in the process, we had a 1/2-inch end mill develop some vibration while roughing the outside of the part. We worked through it properly, we added support to dampen the ring, and optimised the feed rate for the fixturing and updated the cam file. By the time we finished, we had a solid, stable process. I then got pulled onto another project, so I told the machinist I was training to move on to the next side. I also told him the program had already been optimised. The next morning, I came back to see how things had gone, and there he was, facing the dovetail deep inside some soft jaws. But he had swapped out the 3-inch face mill for a 2-inch cutter. And the feed rate, it was turned down so far you could barely tell that the table was even moving. Then he took another skin pass, even slower. So I asked him, why? He said, I wanted a better surface finish. I thought, well, here's a teachable moment. And sometimes the best way to learn is by experience. The result, the exact opposite of what he expected. Sure, the machine was quiet, but the surface finish looked rougher than a cob. The problem was that by slowing down the feed rate so much, the inserts weren't actually cutting the steel properly, they were rubbing it. When your chip load drops below the tool's effective minimum chip thickness, the cutting edge can stop shearing the material consistently. Instead, you can get rubbing, inconsistent cutting forces, increased heat, and the material being dragged underneath the insert. And that's exactly what we were seeing. Instead of a nice, clean finish, we had a smeared material and small gouges across the surface. Modern carbide tooling is designed to cut, not rub. And here's the interesting part. When you're trying to improve surface finish, slowing down the feed isn't always the answer. Sometimes, increasing the feed slightly can actually improve the finish because you're restoring the chip thickness and the insert needs to cut properly. The feed override dial is a useful tool for making adjustments and evaluating what's happening in the cut, but it isn't a surface finish knob and it isn't a tool life button. The best machinists don't react to every vibration or unusual sound by automatically slowing the machine down. They listen, they observe the chips, and they look at the finish. They understand what the tool is doing and why. Then they make adjustments based on the cutting mechanics, not just instinct. The lesson? Slower isn't always better. If you reduce your feed rate too far, you can take a tool that's designed to cut efficiently and turn it into a very expensive rubbing tool. So the next time you see a rough finish, don't automatically reach for the feed override and turn it down. Take a step back and ask yourself, is the tool actually cutting or is it just rubbing? Have you ever slowed a cut down thinking it would improve the finish, only to make things worse? Let me know in the comments. I'd love to hear your experiences from the shop floor. Thanks for stopping by Chuck's Corner. Stay safe, stay sharp, and own the process.